This is the tutorial for CC8NS1A1, which we are trying to determine, or at least know, that numbers that are not rational are called irrational. This is what the standard is asking us to be able to identify here. So when we're dealing with rational and irrational numbers, we are in the real number system. And when we're dealing with the real number system, again, we said that we combine, or we break up the real number system into two different types of numbers, and that's what I've done for you here. And so in the real number system, we have rational numbers, and rational numbers are numbers that can be written as fractions. For instance, 2 1/4. If I took 2 1/4 and I wanted to place it on a number line, I could do that with a rational number. And so that's what I'm going to end up doing here. So what I've done is I've drawn this number line here, and I've broken it into 2 to 3, and it's into 3 different segments. So I could take 2 1/4 and place it on a number line, and that's what I've done here. So I've drawn the number line 2 to 3, and then I've broken it into 4 equal spaces. So this is 2 1/4 right here. And so that point right there would represent 2 1/4. And so that's what you can do with rational numbers. They can be written as fractions. Therefore, we could end up putting them on a number line. Where irrational numbers are numbers that cannot be written as fractions. And so if we had, typically we're going to end up seeing square roots that are not perfect squares. So like, for instance, the square root of 5, not a perfect square. But I do know that the square root of 5 is in between two perfect squares, the square root of 4 and the square root of 9. You see, 4 is a perfect square, which is 2, and that I could put on the number line. See, I could put 2 on the number line there, and I could put 9 on the square root of 9 on the number line as well. I know that's 3, but the square root of 5 is in between these two, but I really just don't have a good approximation of where it's at. And so I know that it's somewhere close to about 2.23, but then it continues to go on and on forever. And so we can't place it on a number line. I know it's somewhere around here, but I don't know exactly where. So irrational numbers are numbers that cannot be written as fractions, and I can't really place them exactly on a number line. I can give a good approximation. I know the number's pretty close to 2.23, which would be pretty close to this number here, but that's not exact. So that's the difference between rational and irrational numbers. Now, with rational numbers, we can be more specific. We have specific types like integers. Integers, again, still numbers I can write as a fraction, because -3 I can write as a fraction as -3/1. And these are integers, numbers that are on the number line. Whole numbers start at 0 and they work their way up. So they're basically the positive integers along with 0. Natural numbers are just the positive integers without 0. So the directions will ask us to identify the names of each real number. So what you have to do is take the square root of 49 and see what it is. Well, it's 7. And so 7 is a rational number, a number I can write as a fraction and put on a number line. So what we'd say is it's rational. Well, first of all, let's start with real, because it is real. So even irrational numbers are real numbers. So we've got a real number, we've got a rational, we also have an integer, because it is 7, and I can put that on a number line, and we also have a whole number. And we have a natural number as well. So we have all the categories of a rational number in this one number of 7. Square root of 10 is not a perfect square. And so when it's not a perfect square, that means I'd have to approximate it. And so what we call that is an irrational number. A number I can't place on a number line precisely. I can give a good idea about where it's at. It's pretty close to 3, but just a little bit bigger than 3. I don't know exactly where it's at. So that is an irrational number. And so irrational numbers, we said, are numbers that cannot be written as or are not perfect squares, but we have some other examples as well. So numbers that repeat, like this one here, 5, 6, 2. And notice how it goes 6, 2 again, 6, 2, 6, 2, 6, 2. So the 6, 2 is repeating. Well, with repeating bars, I can write this as a fraction. So this can be written as a fraction. And there is that algebra trick that allows us to do that. Remember, we'd set x equal to 0.562 and repeated, and then we'd end up using some algebra to figure that out. So this can be written as a fraction. And so what we would call this is a real number and rational, but not an integer, because it's not a number that's on the number line precisely. It's a number between values, and so we would have just real and rational. This one here, 36662, 36662, 3666662. So notice how it's not repeating in a pattern. There is a pattern to it, but the part that repeats is not in a pattern. And so since the repeating part is not in the pattern, it's not always just 2 6s and a 2, 3, 2 6s and a 2. The 6s are increasing each time. So not repeating in a pattern to say that they're the same numbers that repeat each time. So this is irrational. So what we'd say is this is real, and that's what I should say on number 2 as well. So number 2 is real and irrational, along with number 4 as well. So it's real, but it's irrational. And again, the reason is that pattern is not the same, not repeating in, and maybe we should say, the same pattern. So let's take a look at this one. Let's see if it repeats in the same pattern. We have 0, 1, 5, 1, 1, and then 5, 1, 1, 5, 1, 1, and then 5, and then it looks like it continues in that. So let's see the part that repeats. So it's the 1, 5, and 1. So 1, 5, and 1 repeats there. 1, 5, and 1 repeats there. 1, 5, and 1, 1, 5, and 1. Yes, so 1, 5, and 1 continues to repeat. So we would say this is real and rational. And the reason is that we can put a repeating bar over the part that repeats. So those are the types that you're going to see on tonight's homework. Good luck.